Okay, so now let's start. Okay, so introduction now. What happened when the... Okay, we're going to start now. Before that, we already studied amplifier. We studied Class A amplifier, right? A single stage Class A amplifier. Why no? Oh. Okay, that means we used to help us to amplify the signal. Correct? Okay, now what happened if after the amplification is still not high enough? Yeah, we can actually amplify again, okay? So when we amplify again, it's not called single stage amplifications. Okay, so it's called multi-stage amplification. Okay, so we use multi-stage to help us achieve the gain that we want. Okay, that we can't achieve using a single stage amplifier. So now we're going to talk about the methods, okay, that we can actually link up this type of individual stages of amplifier. Okay, so we're going to talk about three types of methods. Okay, three types of methods. So these are the three types of methods that we are linking individual stage together. Okay, so the first type is called the direct coupled. So later I will show you with diagrams. What do we mean by direct coupled? Okay, second one is transformer, and third one is RC coupled. Now under these chapters, basically you need to understand what are these three methods and the advantages and disadvantages of individual types of methods. Okay? Follow? Follow, So let's go to the first type, which is called the direct coupled. Okay, now if you look at the diagram on the right, on your right, okay, you will see that. Can you see that there's Q1 and Q2? Q1 and Q2? Okay, now your Q2 is actually connected to your collector of your Q1, correct? So Q1 is configured as common emitter or common collector. The Q1 configuration is configured as a common emitter or common collector. Okay, what I'm referring is now, I'm going to box it up. Okay, this is my Q1. Okay, so this Q1 is under what type of configuration? Common emitter or common collector? Okay, common collector. Okay, common emitter. So now, common emitter, Q1 common emitter will give you the first stage of amplifications. Correct? And it appears as your input of your Q2. Correct? Input of Q2. Now your Q2, can you see where is the load connected to Q2? Where is this load connected to U2? Which part of U2? Which terminal of U2? Q2, sorry. Collector. So if it's connected to the connector, it's also a common emitter. So when we amplify first stage, common emitter, then we go through second stage, also common emitter, we will actually get higher amplifications. Okay, because the gain, this is called cascade gain, meaning they actually combine and then give us the combined gain. Okay, remember in chapter 1 we have this diagram, right? A1, then we connect to A2. Remember this in your tutorial? Okay, this is what we are doing now. Okay, this is called a cascading gain, okay, or amplifications. Now, why we call direct couple is now, can you see that this part, okay, I'm going to erase everything away. Can you see this part that is linking your first stage and your second stage? There's nothing in between. It's just a direct connections. Okay, it's a direct connections. There are no components or nothing in between the connections. Okay, that's why it is called a direct couple methods. Okay, you are directly coupling the second stage, okay, to the first stage output. Okay, so it's like there's nothing in between them. Okay, so now this method is very direct. As I said, just connect the output to the input of the second stage. Now, what is the advantage? Anyone? Make a guess, make a guess. There must be advantages and disadvantages. Okay, so circuit, yeah, circuit looks simpler. It's simpler because it just connect directly. Okay. Now, can you see that there's nothing in between? Any signal can go through. 0 hertz can go through also. Let's say your output on your first stage is 0 hertz. Can it go into the input of the second stage? Can, right? So that means the 0 hertz signal or DC signal can pass through. Okay, can pass through, reach your second stage, and then get amplifications. Okay, that is one of the advantage. Okay, but it's also a disadvantage. Okay, why is it so? Huh? Okay, now you study DC analysis. Okay, your Q point is determined by what current? Your IB, right? Okay, so can I say that this is IB2 that's going in? Okay, and this IB2, let's say if the first stage happens to amplify a DC, okay, and it come in and add on to my IB2, will my second stage Q point shift? Okay, so it will cause my second stage Q point to shift. Okay, because we want, now we know that common emitter class A, we want the Q point to be at the center. Okay, so that we can have undistorted output. Okay, but because of this, direct coupled method, nothing to block or what, okay, the DC may go into your second stage, and it actually will affect your second stage Q point. Okay, and your output may get, cut off or saturated. Okay, so that is the disadvantage. It's also one advantage, is that because it can allow 0 hertz. Okay, but because of this advantage, it cause another disadvantage, which is it will affect your Q point. Okay, now any more disadvantage? Any more? Now you all study input and output impedance, right, during your AC analysis. Okay, what happens if your impedance don't match? When there's a mismatch of impedance, this one should be covered in your AEF also. What happens if it don't match? Come on. Okay, now, okay, if I have this, okay, this is my first stage, Okay, this is my first stage. Okay, this is my second stage. Now this is input, this is output. Okay, this is out, this is in. Okay, now you all study this. Now, if I give you a single stage common amplifier, you can determine what is the input impedance, output impedance. Correct? You all have done this in your MST. Okay, now, if this output of the first stage and the input of the second stage, okay, because they are direct coupled, meaning they are linked together. Correct? Directly linked together. So if, for example, if this is 4.7K and this is only 2K, can you see that the impedance is a mismatch? Okay, when there's a mismatch, you will have what we call no maximum power transfer. Okay, no maximum power transfer, meaning I cannot transfer the full power from first stage to the second stage. Understand? So this is when there's a mismatch, there is a loss of maximum power transfer. Okay? And this is a disadvantage. Okay? This is a disadvantage, meaning it do not allow maximum power transfer. Okay? Because of the mismatch of the impedance between your first stage output and your second stage input. Okay? It's called a mismatch of impedance. Clear? Clear? Any questions so far? Any more disadvantage? No. Now, advantage, as just now Liner I mentioned, okay, because direct, there's nothing in between. So the cost is very cheap. Okay, the cost is cheap. So that is the advantage. Okay, so this advantage is basically talking about the change of the Q point, because it will affect your second stage Q point. Okay, and also the just now that I draw, okay, the impedance don't match between the two stages. Okay, so if they don't match, you will not have maximum power transfer. Okay, so in terms of your performance wise, it is not so good. Okay, clear? Simple. So direct method, simple. Now, how to identify direct method is, you must make sure that the output of the first stage and the second stage of input, when they connect together, there's nothing in between. Okay, that is how you identify a direct couple. Okay? Okay? So I'm going to go through the next method, which is called the transformer couple. Any question on this first before I proceed? Too slow? Too fast? Which part you don't understand? First to second. Okay. First to second. Okay, now, first you all can identify which is first stage, which is second stage. Okay, so now this Q1, okay, if I draw it this way, okay, this part here is your first stage. Okay, this part here is your second stage. Follow? Follow, So now your first stage output, this is your output, okay, is linked to your second stage input. Alright? And the linkage is direct. It's just a wire connecting. Okay? So nothing in between. So that's why it's called direct. So if we break them into two simple blocks, okay, we know this is Z in. Okay, we know this is Z out. Okay, this is Z in. Okay, this is Z out. Okay, this is second stage. This is first stage. Okay, so both stages will have their Z in and Z out, correct? Okay, so now because direct coupled, meaning we connect the first stage to the second stage directly. Okay, so we link them directly. So you find that Z out and Z in are connected together. Okay, and we know that Z out and Z in, by connecting like that, they are not equal. The resistance value is always not equal. If you done your AC analysis, you realize that your Z in and Z out is always different. Your Z out is always what? RC, right? Correct? Based on your AC analysis, if you see from the output side, you only see RC. Correct? But if you see the input side, you will see that it's always RTH parallel HIE. Correct? So you find that the value is always different, right? Okay? So when they are different, okay, they will be affected by what we call impedance mismatch and poor power, maximum power transfer. Okay, and this is a disadvantage. Okay, so because of poor power transfer. Okay, clear? Clear? So basically for this direct coupled, okay, you have this disadvantage. Okay, but the advantage, as just now I mentioned, okay, because this part is directly linked, okay, if the output here will give me a 0 hertz, it will actually pass through. Okay, it will actually pass through. If. Okay, but we also know that if we allow this current to come in, this is IC1, right? Alright, and we allow a path for IC1 to split. Okay, we allow it to split. The Q point of the stage 1 and the Q2 and the Q of the stage 2 will also be affected. Okay, we want the Q to be in the center. Remember this load line? We want it to be center. And this one is actually affected by your IB. If your IB change, this Q point will shift. Okay, when it shift up or shift down, it will actually affect your waveform, right? It will affect your waveform. Okay? So we do not want this Q point to shift. But when it shift, due to this effect, we can't control. Okay, we can't control. Understand? So direct coupled has this disadvantage also. Okay, the Q point is not stable. Okay, it's not stable. If you operate it at different environment, it will change. Clear? Because the current changes, the IB changes. The IB will change now because now this is IC, right? This is IC, right? Now we know that IC is what? Is beta IB, right? Okay, if IC change, IB will change, right? IC is the collector current. The current that's flowing down through the collector, okay? Go and recap back. Okay, now next I'm going to touch on the second method.